So hi guys, today we have another problem, that is longest subsequence 1. Basically you are given an array and you have to tell the longest subsequence, and what can be the subsequent. Basically the condition, that is you have to keep all the elements, adjacent elements, that the absolute value of the adjacent elements must be equal to 1. Suppose you can take a subsequence that is 4 5 4. So what is the adjacent element absolute difference? That is 1 here and also 1 here. So we can take this subsequence, but we have to tell the longest one, basically the length of the longest one. That will be our answer. You can see that you can take 10 9 8, and it will make the answer of 3. And also you can take 4 5 6 and 4, sorry, 4 5 4 and 4 5 6. That will also make the distance of, sorry, the length of 3. Okay, so here you can see there is a multiple answer, but we have to tell the maximum one. So this is the question, and here you can see that the whole subsequence satisfies our condition, so the answer will be 5. So this is the question that they are asking for. So let us take this example and discuss for further approaches. So what can be the approach? Whenever you are asked for the subsequence, you can generate all the subsequence and check for the validity, if it is valid or not, and have the maximum length and return the answer. So what can be the time complexity for that approach? That will be 2 to the power n. That will be huge. Basically the exponential time complexity that we cannot allow here. Okay, so what can we do? You may think like, okay, so we have to reduce time complexity. Then we can use the DP to reduce the time complexity. And yes, you can use the DP, but still it will make a time complexity of nearly n square. And let us discuss for the tabulation method for that. So for each single value, if you are given a single value, the answer will be always 1. So I'm initializing all the values to 1. And we do not need to bother about for the first element, because it will always make the answer 1. We will start from second element. Okay, so on 9 we have to check from the first, and what is the condition? That is the adjacent element, the absolute value of the elements, that should be always 1. So here we have to check for that condition also. 10 and 9, will it make the absolute value 1? Yes, so we can take this value. For 10 we have this value, so we can add this value to the current element, so it will be 2. For here we have to check from the first again and get the uh, maximum value that we satisfied with that condition, and you can clearly see that no one satisfied with that condition, so we cannot take anyone from the previous value, so the answer or the value will be 1 as it is. Okay, for 5, what will be? You can clearly see that only 4 is satisfied with that condition with 5. So we can take the value of 4 and sum with the current value, that will be 2. And same procedure follows for here. You can clearly see that only 5 is 5 makes the pair. So it will be 3 by 3. What is the value of 5? That is 2. We have to add 2 into the current value of the 4. Now the value is 3. For 8, you can clearly see that only 9 is matching with 8. So we have to take this value and add to 8. I mean add to the value of 8. So it will be 3. And 6, it is matching from here. So 6 will be, the value of the 6 will be 3. So what is the greatest one or the biggest one? That is 6, sorry, 3. So the answer is 3. And you can use this approach also to solve this question, but the time complexity will be in square. So we cannot use this approach. We can further optimize this. How can I optimize this? You can observe that when I am finding from the previous elements for the I, we are we are finding from the 0 to I minus 1 elements. And how can we find that? That is a linear order, right? So it will cost me around n time complexity. Somehow the finding, if I make the finding into the order of one time, then it will be reduced a lot, right? And for searching, if I want to make the time complexity order of one, what data structure can we use? Obviously map. Now the question is, what element should I find, right? Now carefully observe that. For 4, which kind of values I want to find? Obviously for 4, I want to find 3 and 5. Only 3 and 5 will satisfy with 4 and make the absolute values 1. So now we have got which value I have to find and which content I have to put into the map. Okay. So this will be our approach. Let us have a dry run, then it will be clear to you. Let us erase these things first. We do not need this thing anymore. Okay. So let us make the map. Suppose this is the map, and for initial value, obviously the value will be 1 for 10 here, and for the next value, that is 9. So which kind of values I have to find for 9? That is 8 and 10, the previous one and the next one. So we can clearly see that we have 10 already into our map, right? So we have to take this value, basically the value for this key, and add the value here. So for 9 it will be 2. Initially all the values will be 1. So whenever we can find any value that we are searching for, we take the value of the 10 or that value and add to the our current position. Okay. So this will be our whole process. Now for 4, which value I have to search? That is 3 or 5. Do I have 3 and 5 here? No, I don't have. So it will be clearly 1. For 5, this will be 4 and 6. We have already 4 here. So what will be the answer? That will be 2 here. This value and current one, it will make 2. So for 4, which value you have to search? That is 5 and 6. And obviously you can see that 4 is already present in here. So you do not need to write this thing again. So you just have to update here. So for 4, which can we can clearly see that we have 5. And what is the value of 5? That is 2. So the new answer, that will be 3 here. So let us remove it from here. Okay. 4 is considered. Now 8. For 8, we have to search for 7 and 9. We have 9 here. What is the value of 9? That is 2. So here the answer will be 3. And for 6, which value I have to find? That is 5 and 7. I have find 5 in our map. So for the value, that will be 3 here. Now what is the maximum value of those? That is 3. So our answer will be 3. So this is how we can solve this question, and the time complexity and the space complexity will be linear. So let us try to write the code. Obviously, if you are starting to write the code, already I have discussed the dry run. We have to just simply follow the dry run. So let us make another array. So another map. It will be int. The key will be the value of the elements, and the value, that will be the count of the length. So it will be initialized by m. So first of all, we have to insert the first value, that will be 10 and initially 1. And then we have to run the for loop from int I is equal to 1, I will be less than n I plus plus. Now we have to check for the left or previous value and the right value, if that is present in our map or not. And also there is another condition, we have to get the maximum value. Why I'm saying that? Because in some condition or some test cases, you may see that for 5, suppose there is 4 also and there is 6 also, and 4 has the value of suppose 3 and 6 has the value of 2. Then which one we have to consider? We have to consider the maximum one. So you have to keep in mind also. Okay. So let us declare one variable for that. It will be car initially 0, and if m dot a dot I minus 1, because the previous one, if that is present, then it will be always greater than 0. So if that satisfies, so we can easily put that element into the car, that will be a of I minus 1, sorry, minus 1. Okay. Else, okay, let us not use else here. If m of a of I plus 1, if that is greater than m of a of I minus 1, then we can consider this new m dot a dot I plus 1. Okay. Sorry, not m dot I. It will be a of I. So now what we have in our hand? Basically the element of the maximum length. Okay. Suppose in this condition, what we have in our hand? We have 4 here. And because the 4 contains the maximum length of the subsequence, so we have 4 in our hand. Now we have to use 4 here to calculate the new length. So how can I do that? If car is greater than 0, means we have got some value from the map, then we have to add the previous value plus 1 into our new value, that is int temp will be m dot car. What m dot car stores? Basically the length of the previous element position, that will be int temp will be stored that thing, and we have to make the answer, that will be uh, maximum of previous answer and current temp plus 1. Why temp plus 1? Because we are updating the value with 1, and we have to declare the answer variable also, it will be 1. So now we can update our map, that will be m of a of I. Simply you can use plus plus, or it will be better to use temp plus 1. It will not be plus plus, okay, because we are updating the current position element. It will be temp plus 1. Okay. Else, when will come else? When we have the new element in our hand. So in that case, we have to make our new element to initialize by 1. Okay. So now let us return the answer variable. So hopefully this code will work. Let us try to compile the code. Okay, so it is matching. Let us try to submit the code. Okay, so we have some issue. Where is the issue? Where is the issue? Okay, okay. I have hard coded here. Sorry, I was into that dry run. My mind was there. Sorry, it will be a of 0. Okay, sorry, sorry. Great mistake. Don't do this kind of mistake. Okay, so let us try to run again. So let us try to submit again. Okay, so it is working fine. So the time complexity and the space complexity both are order of n. So yeah, this is how you can solve this question using math. It will be easy to you, and the code will be available into the description. I will provide the link. Thank you very much, and see you in the next video.